I'd like to thank Western Beef for inviting us out here today, and hope everybody's having a good morning so far. My name is Stephen Hughes. I'm from Quantum Genetix, as Kathy just mentioned. And for those of you who haven't heard about Quantum Genetix before, I'll just briefly kind of go through a little bit about us. So the company started in 2003. I joined in 2004, so I've kind of been there since the very beginning and helped them grow through the years. We've got several peer-reviewed publications. We've been doing a lot of research over the past 10 years, and we're now, I'd say in the past 3 years, we've been really just trying to commercialize things that we've been doing research on before. And so we performed over 3 million genotypes. So they say if you do something 1,000 times, you become an expert at it. So we've done it 1,000 times, 3,000 times over. So I think we're getting pretty good at it. Quantum Biosciences is a sister company. We do genetic testing in plants. We do GMO detection in shrimp and flax, which is why we started in 2009. That's kind of when the EU put an embargo on Canadian flax because they found triffid. We also do testing in canola as well, and there's some research projects that in the pipeline that we're working on detection of sclerotinia and fusarium as well. And we acquired Genetix Laboratories this year from SRC. They also do livestock testing. They do more testing for breed associations. They also do testing in other animals such as sheep and alpaca and horses. So Quantum's mission really is to use genetic technologies to improve livestock production efficiency and profitability. So really our goal is there to bring new technology to the industry and allow you guys to become more profitable, make more money. And in order to make more money, your production systems are going to become more efficient by having more information to make decisions from. So genomics simplified, that's our key message now. We want to keep it simple. I know there's a lot of information out there and it gets very confusing, and it's very difficult to decide what you should do, what will be beneficial. So, like I said, we spent a lot of time, we spent a lot of research dollars on a few products, and so we feel that we understand them very well. And so now we can bring that to the industry and try to make it simplified for everybody. So like I said, we do the research, we find out what's going on, we find out what the economic utility is of it, and we can go straight to the producer and say, this is how you can make money with this technology. So the main product I'm going to focus on today is called Q-Link. It's a parentage type test, and what we do is, the goal of it is just to link sires to their offspring. And in doing so, we can find out information about the sires, such as breeding capacity, number one, simply by matching them up, how many calves each one produced. If there's any additional data that can be collected, such as weaning weights, we can also link that up to the sire or carcass data. Now, see these pictures? So how many people, when they're buying a sire, will go and have a look at it? Everybody, is that basic, the basic premise of purchasing a sire? You're going to look at it, you're going to evaluate it based on physical attributes. So which one of these guys would you pick? Well, the second picture's a little fuzzy, but to me they more or less look the same. Well, in actuality, these two bulls, they're in a ranch we did Q-Link trial with already. Bull A, he bred 17 cows. Now these weren't the top or the bottom. It was the middle of the top and middle of the bottom in terms of production from all of the sires that they have. So Bull B, he produced 5 calves. Their average weaning weight, which we adjusted to 205 days. Difference of 80 pounds there. Big number of cost of production. Okay, this is the key thing. Kathy talked about it before. You need to know how much money it takes to produce an animal, because regardless of selling price, if you're spending more money than you're getting, then that's pretty efficient, right? You want to be spending less money than you're gaining in the end. So just a little bit, the cost of production, that was based on Annual cow cost of $750, and an annual bull cost of $1,000.26. The annual bull cost came from my Western Beef Development Center fact sheet from, I believe it was 2010. And I think they used a $3,000 purchase price for the sire, which they depreciated over 6 years. So just so you know, if that brings any evals with your operation or not, maybe your cost of production is lower, maybe it's higher. The main thing is you got two bulls, no matter what numbers you use, the cost of production is vastly different. And the CPM cow, I call it calf profit margin, that was just based on a selling price of $250 for each steer. So from the picture, go back. Bull A or B? Did anybody get it right? So like I said, so this is from a case study that we did in Alberta. It was a very large multi-sire pasture. They were actually using 46 sires and running about 750 cows. All the sires they were all limo, and they have a fairly low bull to cow ratio because it's such a large hilly terrain, lots of valleys with bushes, and cows are able to get in there and hide. So they found that they just need to have a low ratio in order to try and cover all the cows. So anyways, with this group, we found that the breeding capacity had a range of 1 calf to 45 calves. So that means the worst producing sire produced 1 calf or bred 1 cow, and the best producing sire bred 45 cows. The average on the herd was 11.4. Average weaning weight ranged from 394 to 602, with an average of 504. So the cost of production ranged from $3.68 to $1.46. So what's the price of calf selling today, roughly? Pardon? 60? 260. 260. If it costs you $3.60 to make that animal, is that a good price? No. So you want to find these inefficiencies so that you can then improve them later on. So if you're using $250, you end up with a loss of $570 on one of those animals to a gain of $582 for some of those animals. The herd cost of production, just because, is a little bit different. So it's $1.66. That was their overall cost of production. That was taking all animals, all sires together, what their cost of production was, as opposed to just each individual sire and then taking the average of those individuals. So it's just a slightly different number. And that's what we'll talk about in here. We'll use the herd cost of production.
Right.
Yes?
Excuse me, back to your other slide, you have that BC range of 1 to 45.
Yes.
Is there any correlation to the age of the bull?
There could be. I don't have the ages of the bulls. So essentially, what we've done so far is we've done the testing, we've given the information back to the producer. So breeding capacity we can tell right away because that's simply matching up the animals. And they gave us the birth weights and the weaning weights so we could calculate the 205-day weights and give them a report on average weaning weight as well. So this information is from 2013. They've taken this information and they have made some culling decisions based on that. So as far as whether these were 2-year-olds or 5-year-olds, I don't know that. So anyways, these costing scenarios are just they're not actually what happened. These are just some some possible options just to demonstrate a value. So their actual scenario, the cost of production is $1.55.88. So just about $1.66. If you took the bottom 6 performing, now they've got 46 sires. If you were simply to just call the bottom 6 because they were only producing 1 to 2 calves anyways, you can improve your value by $12.95 per calf. That's $12.95 for every calf that you produce out of that farm. Another option is to source bulls from your top performers. Now that you know who is breeding the most calves, who is producing the highest weaning weight, you can go back to where you got those bulls from and find some more like that. So if you do that, and replace 3 of the bulls that had a high breeding capacity but a low weaning weight, we can improve that value to $17.67 per calf. The third option is replacing the bottom 16 sires with 6 that you've taken from your top performers or sourced from your top performers. So essentially you're taking your wide variation in your herd and you're trying to make everything more alike. Okay, you're trying to reduce that variation, and in doing so, you can improve the cost of production and improve your overall value by $23, or almost $24 a head. Is that, so how does that sound to anybody? Would you like to make another $24 a calf? This is from a smaller group, also in Alberta, but they had 9 sires and they run about 140 cows. So from the data we have, 2-year study, you can see 2012 they actually ran 9 sires. After we gave them their information, genotype information, the following year they actually didn't run 2 of the sires. One of them obviously only bred one cow, so they didn't bother using them. Not entirely sure why they didn't use the other one. Could have been injured, maybe he was an older sire, I'm not sure. But point being, as you can see, cost of production varies drastically. Now the weaning weights also went up. That could be due to environmental conditions. The weaning weights increased overall, like across all sires. But what I did in looking at this is I actually just used the same average weights from 2012. So there was no adjustment in weight. This is just a valuation based on cutting it down to 7 sires as opposed to 9. So essentially, in 2013, obviously they only needed 7 sires. 2012, they used 9. You could have got away with 7 probably. So that was almost $30 per calf in value. So we're also trying, Western Beef is also running a project right now. They're evaluating, one of the objectives is to evaluate healing or essentially parentage testing in a multi-sire pasture setting, just in order to sort of further define what sort of value, if any, it does have. Currently we've tested, I don't remember the number off that up, but just some of the steers from one of the ranches.
116, I think there was.
About 116. And so you can see, I mean, the main thing to notice, you're seeing the same thing that we saw with the previous two ranches in Alberta. You're seeing quite a wide range of breeding capacity. There's a range of weaning weights, and ultimately a large range in cost of production. So obviously there's a need, not only collecting data on your ranch, but specifically collecting breeding data so you know what each sire is doing. I know there's a lot of challenges with collecting data, and this is sort of one of the more simpler ones. You collect a tissue sample from an animal, send it in. You don't have to be weighing all of the animals. Simply by knowing how many cows each sire is covering can make a big difference in your future decisions. The cost of production, again, it was based on $750 per year for each cow, but the sire cost was actually based on some actual purchase prices that we had available to us. And again, it was depreciated over that 6 years based on the same formulation as the fact sheet that Western Beef put out in, I think it was 2010. So sort of just, just a summary of queuing. So essentially, it's just a genetic tool to track and measure bull performance, which provides information for management decisions. So this isn't necessarily telling you what you need to do. This is just one of those ways that you can collect data and make decisions to improve your herd. So I mean, obviously, Quantum Genetix, there's quite a few individuals that have a cattle background in the company, which is essentially why our focus is on livestock production. But you guys are intimate with your operations. So we're not going to come in there and tell you what to do. We're going to come in there and tell you, here's some new information that you didn't have before. Or here's a way to get information that you didn't have before. And now you can make informed decisions. In order to do something like Q-Link or essentially any of the tests with us, you collect a tissue sample from each animal. We can use hair tissue, full hair from the tail. We can do blood, but blood's a little bit messier, so we just we don't do it if we don't need to. See, we can test semen on sires, and we can also collect ear tissue. We have, fortunately I don't have the device that I could have brought today, but has anybody seen the blue Vitex tagging gun? Is anybody familiar with that? Essentially, we took that tool and we modified it, we changed the holder, and we changed the pin, and we built our own tissue collection tags. So it's just like tagging an ear with any ear tag. Put our collection tag in, put our punch on, and you just squeeze it on the ear. And then you collect the ear tissue. So it's fairly simple, very quick. We've done it many, hundreds of thousands of times in the feedlot, and we keep up with the processing that they're already doing. So it's a matter of, in a few seconds you can have your tissue sample from any animal. And again, so right off the bat, when you do the testing, you receive the breeding capacity, because that's simply just a match of sire to its offspring. Additionally, if there's any other information that can be submitted to us, we can also link that to each sire and give a report on that, such as weaning weight, or if you have carcass information. There's also VIXIS. Because animals are tracked by the RFIDs, the CCIA tag numbers, even if you're not maintaining ownership through a feedlot, if you're just simply selling them at an auction, if that information gets uploaded to VIXIS, then we're a third-party provider and we can still have access to that information down the road. So just want to touch a little, or actually, are there any questions on Q-Link before I go ahead?
What is the price on
Currently it's $12. And we have been testing a few different producers for multiple years now. And although we don't necessarily formally have a storage procedure for samples, if we have generated a profile already, then the next time, so for the subsequent years, if you're using the same animal, we can go back to the same profile, so you're not necessarily paying every year for your sires. But you have to submit a new sample for each new county. We haven't yet, so just so you know, like GenServe, they do parentage testing for breed associations, for parentage verification. The main difference is a slight difference in stringency. So they need to have it, they have an absolute, they have the sire, they typically have the dam, they're making an absolute call. There's a set standard of how many markers that they have to have tested. In this case, it's more we're using an exclusion principle. So when you give us 10 sires, you give us 150 cows or 150 calves, we're going to test all those, and when they're all excluded but one, we'll declare that as the true match. So we don't necessarily run 100 snips on these animals all the time. In some cases, we may have the same results with 70 or 80 markers. So there's a slight difference in. So with parentage testing for breed associations, the cost is higher. There's differences in data management, the biobanking, just in the difference, just in the stringencies of the test as well.
Okay. Do you have an issue with multi-sib sires if they're brothers or whatnot when you do the exclusion way of it?
We don't. So most of the time, all the samples that we get are blind. Like we don't really know what's coming from the producers, so we don't know how related the sires are. There's been a few instances, a few producers where earlier on, like a few years ago, we were trying to do it, and we were running into some issues where, having multiple matches, and, so talking to the producer, finding out that, yeah, the breed was highly related, but we were able to run additional markers and sort that out. We also have a project going on right now. Actually, Lee Marcus, the founder of Quantum Genetix, he has a purebred Charolais herd, and so he's blind. He hasn't put the samples together blindly. He knows what the parentage is, but he does have half sieves and full sieves, and so that's an evaluation that we're doing internally, and we're also having UC Davis run the same samples to see what they get. And we're doing a comparison with, I believe they're using, it was either 500 or 1,000 SNPs per parentage. We're going to use microsatellite parentage, which we can do in-house with Genser, and we're doing our SNP panel as well, just as a comparison to see how much of an issue that is, or evaluate the different methods as well. So yeah, so in short, it can be an issue, but it can be resolved. And if we use a dam sample as well, then that helps narrow down the genetic profiles too. So just touch a little bit more on some of the other things that we have at Quantum Genetix. So we also test for different performance traits. Leptin, maybe some of you are familiar with leptin, or at least heard of leptin. PMCH, IGF, CRH, they're just acronyms for other genes that have an impact on important economic traits. QSort is our feedlot management product. And we also do some genetic defect testing. And because we have Genser now, we also have additional testing services through Genser and for different species as well. So leptin has been highly characterized. I know there's some information that is conflicting. Primarily it's due to larger populations in their studies. Now, we've been studying leptin for over 10 years. That's how what the company was founded on, was with the leptin gene. For those of you that don't know, leptin is it's another name for the obese gene, and it's involved in the appetite pathway and energy balance. And there's a SNP inside the gene that alters the structure of the hormone. So when the structure is altered, it no longer binds to the receptor and it doesn't submit that signal anymore. So it's basically a feedback mechanism that's either slightly muted or shut down. CC is the wild type, CT is what we call the hetero, and TT is the mutant. So the C's and the T's, so that's just a letter designation to identify the SNP for each allele, one copy from each parent. Now, why this is important to you guys? This is an external study from Oklahoma State, and I believe the other fellow was in North Dakota at the time. So they looked at leptin from the cow-calf perspective. What is the benefit to the cow-calf producer? We spent a lot of time on saying what's the benefit to the feedlot. We've done a little bit on the cow-calf producer. These guys said, what's the benefit to the cow-calf producer? They found out that in terms of production years, TT cows had 2 more productive years than CC cows. So if you're using TT heifers, you're going to get more generations out of those animals. So therefore, your cost of production on those cows is going to be substantially lower. The other thing they found out was the average weaning weight differed by the cow's genotype. So if you're a TT cow, you're going to produce calves with a higher weaning weight. If you're a CC cow, you're going to produce calves with a lower weaning weight. And so the actual difference they found between a TT and a CC cow is over 27 pounds. So what was your 260? 260 times 27 pounds. There's your extra value in leptin. This is just a quick summary. Like I said, we've done a lot of work on leptin. We've done a lot of feedlot trials looking at carcass information. We've tested over 150,000 animals that have been part of research projects. This is just a quick summary. Milk production, TTs are higher. It's a little bit higher in actual volume, plus it's higher in fat content, which makes a lot of sense. If a cow's producing more energy-rich milk, then the calf is going to have more energy to grow. Weaning weight is higher, so again, the TT animals are not only producing more milk, but if you look at dry matter intake, is up for TTs as well, consuming more energy-rich milk, and they're probably consuming even more than their CC counterparts. Back fats, higher for TT animals, yield grade, quality grade, so those are, for a feedlot, their job is to fatten up an animal because everybody likes a nice fat, juicy steak. And so that shows yield grade higher, quality grade is higher. Marbling tends to be higher, which is just another way of talking about quality grade. Hot carcass weight, we've started to pay more attention to lately, and we're just finished up. We're just analyzing data from a serial slaughter trial that we did, and hot carcass weight gain is actually higher in TT animals. So one of the things was, people said, well, but TT animals, they eat too much, they're inefficient because they're eating too much. Well, they're actually not inefficient. They're actually as efficient, or possibly even a little bit more efficient. They're consuming more, they're growing quicker, and so they're reaching the same endpoint sooner. For a feedlot, that's a big deal because now they've got fewer days on feed. Okay, their production system is more efficient. For a cow-calf producer, whatever target you want to sell your calves at, 500 pounds, 600 pounds, this could mean that those animals are ready to go to market sooner. So same, less pasture time for you guys as well. Ribeye area, TTs tend to have a slightly smaller ribeye area. We haven't focused a lot on this, so we haven't made a statistically significant association. But pouring through lots of data, that's a general trend that TTs have a slightly smaller ribeye area, which is essentially if you're a fatter animal and the CCs are the alternate, typically they're a more muscled, leaner animal. So again, like I said, we've done a lot of work on leptin. Here's references of 7 of the trials that we have published or are currently published, plus there's hundreds of other publications by other researchers. Does anybody have any questions particularly on leptin? How are we doing time-wise?